to the third episode of the L-DIH Talks. My name is Ivan, I'm support officer at the Digital Innovation Hub. On today's program, we have a short intro of Test Before Invest services, followed by today's topic, data predictive maintenance. Please welcome our speakers, Laurence Johansen, researcher. Laurence Johansen, researcher at LIST, Andrés Meléndez-Imaz, senior engineer, and Arthur Chevalier, junior IT engineer, also at the LIST. So before we begin, I wanted to put your attention in the question tab in the chat. Feel free to drop your question there anytime. We will address them at the end of this session. And now I give the word to you, Laurence.
Good morning, everyone. Nice to meet you, and welcome to this L-DIH talk on predictive maintenance. I will give a short introduction on the services that we, LIST, are delivering within the L-DIH network, and which are financed at the moment under the L-DIH project. And then I will leave the floor to my colleagues, Andres and Arthur, who will present you what we're here today for, the predictive maintenance, and how to use AI to do that. Next slide, please. Okay, so we are part of the L-DIH network, which is aimed at supporting manufacturing companies into their digitalization. And as a research and technology organization, we have many skills, infrastructures, and services and projects to help you digitalize. Among the infrastructure, we have a visualization wall, which allows the visualization of large-scale data and navigating the models within them from a tangible table so that different stakeholders can make collaborative decision-making, navigating these sets of data or digital twins together. We also have a cognitive environmental lab to support decision-making, an immersive arena, many workshop showrooms. We also have a car lab to study things related to autonomous driving and vehicles. We have a mixed reality lab, which we have already had one of these talks on, to see how you can use extended and augmented reality to do maintenance on machines. And we have a connectivity 6G lab. Next slide, please. So within the L-DIH network, LIST is committed to test before invest services. That is giving you the opportunity to experiment, to discover, to test some technologies and understand what they can do for your business, how they can meet your business challenge. So the first service that we deliver, as they are very progressive, is the L-DIH talk like we are having today. This is totally free. This is a 1-hour presentation on the use of technologies for Industrial 4.0 challenges. And it's kind of an appetizer for what comes afterwards, because if you enjoyed the topics and want to go further, then you can go for a hands-on tech test. That is a half-day workshop. It's on site, whether at your company or at LIST, where you can test technologies hands-on based on real industrial use cases. So we have the workshop related to today's webinar. It's planned, I think, in June. I will tell, it's in the next slide, so I will tell you. And you will be able to test some technologies for modeling data and do predictive maintenance. These tech tests are totally financed for manufacturing companies within the L-DIH project all you have to do is register on DIH.lu and take the terms and conditions to access those webinars, and so that they are financed. If one of the technologies that you have been testing during the workshop or discovered during the webinars is really interesting you, if you have business challenges that you want us to help you address and to support you within your digitalization roadmap, then you can go for the third service, which is called Digital Opportunity Assessment. And this is dedicated to one company. So we come to you. We come and explore your business challenges, whatever they are, process improvement, quality of products, strategic positioning. And we propose you some techniques, AI, data analytics, connectivity, etc., dashboarding, to see how we can help you solve this problem. And during a second workshop, we explore your maturity, so we can design for you the best development plan for your tailored digital solution. And this is financed within the project too. I will tell you the conditions afterwards. If you go to next slide. I'm doing as fast as possible because I guess what you're interested in today is predictive maintenance. So the DIH Talks, as I told you, are webinars, 1 hour webinars or presentations. We've already treated subjects like data and AI, connectivity in industrial automation, no-code platforms. We visited the LIST Composite Manufacturing Lab. We've had some blockchain, extended reality using Unity and data storytelling. And today we are having data predictive maintenance. End of April, so it's always going to be on Friday, 11 a.m. End of April, we will have one on visual inspection, so how to use image processing to analyze the quality of your products. And May, one of user-centric design, how to design the best user experience for your customers. Then we will be present at Nexus 2050, and please come and visit us. We'll be able to answer all your questions. Then end of June, we'll have one on IoT prototyping, and October is planned one on the AI Act and how to best manage your data according to that. And other ones will be planned end of the year. So that's for the talks, the Friday morning talks. And if we can come to the next slide. So these are the workshops I told you about, the half-day workshops. And on the right hand, you can see all the topics that we can treat for you. We have some planned, but we can do some on demand too. So yeah, I told you it would be 19th of June, the workshop on predictive maintenance with AI. So alpha day to test technologies, solution, and go through the use case. September, we'll have one on data acquisition and visualization, so how to acquire data from your machines and manage them and build a dashboard. On October, we'll have the workshop on extended reality. November, UX design. December, data storytelling. And January, we'll have one again, the workshop on blockchain for industry. And in February, we will have the workshop on visual inspection. So you feel free to register, and you are most welcome to join us for those hands-on tests. And if you want to go further to the next slide, this is the tailored solution I was talking to you about. So 2 workshops, one to explore your needs, challenges, and business problems, and see what data you have and what skills and solution our researchers can propose to help you. And in the second workshop, we go for your capacity, so the maturity of your infrastructure, data, and skills. And at the end, you have the book of requirements under the form of a project proposal, so you can directly go for funding with that to develop your own solution, either with us during RDI research project, which is really well financed by the Ministry of Economy, or go on the market or develop it yourself. All you have to do to access this service, totally financed both by the project and by Ministry of Economy, is take a light DMA, that is a questionnaire online developed by the EC, which will give you your maturity in 5 domains, and you will get at the end a diagnosis and recommendations to improve your digitalization. So all you have to do to access our tailored support, is to take this questionnaire online. Excuse me. And now we can go for the next slide. And I will give the floor, before I die, to Andres and Arthur.
Okay. Hi, I hope you can hear me. I'm Andres, Arthur. If you see us looking that way, it's because actually we have a big screen explaining everything, so we're probably going to be facing that time all the time. So, predictive maintenance. The agenda for today is kind of short. It's like understanding why understanding predictive maintenance as a sense. Then from data to predictions, usually what you do in terms of machine learning. We're going to study one specific case, which is the Bosch predictive maintenance implementation. And then we're going to finish talking about challenges and best practices in different kind of projects related to predictive maintenance, but also about machine learning. So going further, understanding predictive maintenance. Okay. Predictive maintenance. First of all, to try to understand what predictive maintenance is, we need to actually try to compare with some different, let's say, approaches. Reactive maintenance and preventive maintenance. Reactive maintenance is the repair of equipment only after it breaks down. For example, pros on that is like there's no upfront cost or minimum planning. And the cons on that is that actually the unexpected failures or higher downtime or costly emergency repairs. If you want, you can think about, like, for example, if you buy a new a car that actually, and you don't have any money to actually repair it. So when it breaks, you try to repair it. Every time that if something happens, you try to repair it. So this is let's say, the easiest way. Easy because you're not thinking about the repairment, but then it's costly because, of course, maybe because you didn't actually make a preventive change or something, you need to make a bigger cost on repairing. Preventive maintenance that is performed at the regular intervals regardless of the equipment or condition. Pros on that, it reduces the unexpected failures and extend the asset life. It means that actually, for example, the car, actually you can extend the life. The cons is that actually you can lead to unnecessary maintenance and increase the cost. For example, if you change, the brakes that you need to be changed because actually the brakes were fine, but since it was just preventive in case it actually fails when you're actually driving. Another way to think about preventive maintenance, and this is actually going to lead to the next slide, is regarding to airplanes, for example. Everybody knows that the airplanes, they have a preventive maintenance because if something fails during the flight, you cannot really change it. And you can, let's say that the cons are really high because it can lead to an accident. So that's another way to think about the preventive maintenance, like the preventing change on spare parts on an airplane before something bad occurs. So what is predictive maintenance then? Is the data-driven approach that uses real-time monitoring, sensor, or advanced analytics to predict when some equipment will fail. By analyzing historical or live data, it allows maintenance teams to perform repairs only when necessary or before failures occur, but without unnecessary interventions. So let me see. Yeah, the next slide. In this case, there was a use case, and I'm sharing here a paper that was actually I was working on this when I started in Luxembourg as a data engineer for this project mostly, and the idea was to try to predict when some part of the airplane is gonna fail. It's going to fail. So by analyzing all the sensors that an airplane has, it was kind of like problematic because, of course, the sensor of an airplane, they measure some stuff, but of course not everything. So, for example, you can have a sensor for the tire pressure, but maybe you don't have a sensor for every screw that is inside an airplane. So how can you actually try to predict that one screw is going to be loose or not? So in some cases, you cannot really predict every part of an airplane, but you can actually predict something that is attached somehow to a sensor of live data you can have. Okay, sorry. So going forward, from data to prediction. The idea is to explain a little bit about the data life cycle. In this case, it's very important. The starting point is the business understanding. It is very important to understand what is the question that you can ask to the business partner in this case, or to define define also the objectives that you need to predict, or do you need to solve the problem that you want to solve. It's really hard. This part is like we just put in one part of the slide, but it's like mostly the crucial part. Understanding the problem, understanding the solution that you can actually achieve with that is something that actually is not only one shot. You can actually try to do it many times. So that's why usually you should have like recurrence meetings with the partner or with the person that you're working with. After that, you can actually start the data mining process. With actually, data mining is not the data mining as we usually know, because data mining before was the process. I had it written here. It's the process of using a statistical analysis and machine learning to discover hidden parts or correlation or anomalies. In this case, data mining is mostly about how to get the data, how to scrap the data. It's like how to mine to get the data that you need, and not just, let's say, useless information that you don't need to actually try to make a prediction. Then the data cleaning is also an important part, because of course you can gather a lot of data, but that data maybe is not in the correct format, or maybe has some missing values in between. I'm thinking, yeah, mostly that. Then the data exploration part, or EDA, exploratory data analysis, distribution of data inside different features, visually analyze data, try to understand the data that you have, and try to see if you can correlate different type of sources that you have, which is not always the case, and is kind of also let's say, one of the biggest challenge. Then is the feature engineer, where you select the important features that you want to work with, and you create also meaningful ones. Like, I don't know, for example, if you're working in a bank and you have the salary of somebody and you have the transaction of somebody, maybe a good feature engineer could be created the balance by monthly balance. So you can understand actually if something is going up and down, and then you can predict, for example, if you're going to have a bigger income. Predictive modeling, to train the machine learning models, evaluate the performance, use it to make the predictions. This is also important. Of course, everything is important, but it's like in specific cases. And you can always go back to another one. So, for example, it might happen that actually you are doing the feature engineering, and then you're missing a value that you're not getting by the source that you have. So maybe you can go back to the data mining part and try to get other sources to try to correlate it better. And then also in the predictive modeling, let's say that the part that you are training with maybe is choose parts, or you're training with data that is not really useful for the model. So maybe you want to understand better what kind of data you have, and then go back and try to train with the features that you need. And then the data visualization part, which is actually super important if you want to, let's say, at the end of the discovery, try to communicate the results, communicate the insights that you found. Even if it's not exactly what you were expecting to solve from the beginning, maybe it's a good idea to try to understand how to communicate with other people, to try to show them like different aspects of your findings that might lead to maybe other problems or maybe other type of solutions. So explaining little by little these parts, we're going to start with the data mining. The data mining part, or the data acquisition part, let's say, it could be done by acquiring data from private data sets, which are specific to the partner. Like, for example, in the terms of the airplanes that I was telling you before, one of the challenges that we have was actually how to get the data from the airplanes. And since it's not live data, because you are not really broadcasting through the flight, what we did was actually connecting a pen drive to the airplane, getting the CSV files of all the sensors that were working there. And that's actually super private from a specific airplane, a specific brand, from a specific vendor, and the usage of that airplane. In other cases, you can actually interact with the public data sets. Here I'm putting some of them, which actually we are using currently in a lot of projects that we have. Public data from Luxembourg. Also, okay, no, maybe not France, but yes, from Luxembourg. We have different data of, let's say, traffic information, weather information that we're using in different aspects, not only for predictive maintenance, but for other projects also. And then other ways to gather information is not just by using private data sets or public data sets, but this the way is like a web scraping. And here I put some libraries about that. I should have put more maybe, but yeah, like some of them that actually we use here to scrap data is like Beautiful Soap. It was a nice library. And also, for example, if you want to get data from Twitter for like live streaming, there's another one. The data cleaning part. Maybe I'm going to assume that actually all of you know what pandas is and Jupyter notebooks are. In here, like really well-defined functions that you currently use every time that you get a new data set are like ways to analyze the data. Like, for example, the dates in a CSV file or a JSON file, they're usually strings. They're not really dates that can be interpreted by the computer. So in some cases, you need to actually change that data type. You need to understand also the data types that you have in a data frame. For example, every time that you put it from a CSV file, you want to understand, like in some cases, it actually tells you the data type that you have. And in some other cases, because you have missing values, maybe you don't. Then removing unwanted columns is also super important when you are dealing with data that has, like, for example, the public data that you might have a lot of information that is not really useful, for example, descriptions or status that you don't need. So they're super important to remove those columns. And also, let's say one of the most important functions that I use many times is like how to actually work with the null values. In some cases, you want to remove all the null values because you don't want data that is that has nothing to do with the stuff. But when you're removing a row, maybe you are like missing some information that is there just because you have a date that is not null. So one thing that you can do is like fill those values with the mean. For example, if you are talking about I don't know, the age of people in a school, maybe you can understand if they are in the same classroom, you can put the same age for them if you have a missing value. And in other cases, like for example, you can do this method that is like forward fill or like backward fill, that actually it fills the information from the row that actually has some information from before or after. Super important when actually you don't need you don't know anything about the column itself. And also another one that is maybe useful is the completed with the median of that number. In some cases, it doesn't make sense. Like, for example, the median of an age, it doesn't make sense because maybe it doesn't give you like the right value, an integer value, but it gives you a float, for example. And then, of course, you have other methods like removing duplicates that might be useful. Sorry if I went too deep on that. Other parts is the exploration of the data. In here, I'm sharing a really useful one. I don't know if you can see it because it's too small, but it was the pandas profiling which actually changed name. Let me see if I can see it here. It's called Y profiling now, because actually the library was it changed a little bit. And what it does is just give you the exploration of the data itself, and it gives you a lot of insight on the data without really doing machine learning. Like it gives you data. At some point when I started this data analysis, I was doing it by myself. I was trying to understand the correlation of the features. I was trying to understand I don't know, if I have new values, if the values were unique. And in this case, this tool actually gives you a lot of this information. It creates a report from scratch from a data that actually is really valuable. And you can see a lot, like for example, if you have like unique values or null values, or if it's always the same value. For example, in here we are exploring charging stations that actually we got using the scrapper that we mentioned before. I think, yes. And in that case, they have coordinates, GPS coordinates. And this part, let's say this report, it gives you that all the coordinates are unique. So that's a good sign that actually the data that you have is really good. And in other cases, it tells you that actually the name of the charging station is the same, which, okay, maybe because it's from the same vendor, they just put the same name, so that's fine. And it can give you the correlation of some variables. It can give you the map of names, for example. So really good, let's say, data or exploration data that you can find from any kind of data set. Then the feature engineering part. So features are different depending on the type of learning that you want to do. So for example, if it's supervised learning, the text is not visible from this EDA slide. Oh, I'm so sorry. We're gonna share the slides later, right? Yeah. Okay, so later when we share the slides, you can see mostly. But if I can, I will write it in the comments the type of library that I'm using. Okay, sorry, Catherine. So again, I was saying that feature engineering. Features are important if you are the most important part of, let's say, of the data, is the characteristic of the data. In supervised learning, the features are the algorithm input variables for prediction, and in unsupervised learning, features are used to identify data patterns, to try to understand the data without really understanding the categories. And you can always add new type of features, like for example, numerical features. There are continuous values that can be measured on a scale, for example, age, the height, the weight of people, the income. Then you have categorical features, which are discrete values that can be grouped into categories. Like gender, color. And I put one here that is kind of weird, this month. Month is a numerical feature, but also could be displayed as a categorical feature. And why? Because you have a correlation between the month. You know that actually April comes after March, but when you translate into numbers and you have you have 1 until 12, you don't have the correlation between 12 and 1. And that actually can be a problem if you're training a machine learning model with only the numbers. So it gives you like a really long distance between January and December, but actually you know that actually after December, January comes back. So it can be tricky. So that's why I put it in the categorical ones. Then you have time series features, where it actually is like measurements from data taken over time, like stock price or sensor data, weather data, and then text features that are like text strings that can be represented by words, phrases, and so on. Modeling part. The modeling part is super important. It's like you have supervised learning, when you can have classification or regression methods. Here I'm mentioning a lot of them. Maybe you can look at them later. Unsupervised learning also, reinforcement learning, which is actually when the training is taking a feedback from the training, and rewarding if it's a good decision, or penalizing if it's a bad decision. But then the important part also is like, okay, if I have a model, I don't want to like go further on the models itself, but if you have a model, how can you evaluate if a model is good or not? How can you understand if the training that you did is actually a good one or not? Or can you generalize the data that you didn't see? Or how can you compare with other models? And this is where actually you go with the validation. Like holdout validation is the most typical one, when you have a set and you divide that set into training and test, and then you create a machine learning model with one part of that set that is called the training, and then you test it on the rest. Usually 70-30 or 80-20, depends on the case. And there were other type of validation, because it might happen that actually you are training with a part that the data is sparse or is not good enough or is not so representative. So how can you know if what you're doing is really good? So that's why it comes with the cross validation, where you divide the data in different k-folds, and then what you do is try to, let's say, only the test part you are moving, and then you're saying, okay, I'm going to test with all this part, and then, sorry, I'm going to train with all this part, and then going to test with this part. But what happens if actually if I divide the data in k different parts? I want to test with different parts to try to understand if I'm using all the data. Let's say there is. Sorry, I got lost. If all the data I'm using actually it makes sense or not, because actually it might happen that the data that you're training with is not so representative. So maybe in little parts, by dividing little parts, you can actually represent the whole model by itself. And then, of course, at the end, you can actually make a mean of all the results. And then, of course, you have the metrics evaluation of each model. For example, for classification problems, you can have accuracy or precision, recall, F1 score. And for regression problems, you can have mean square, mean absolute error, or R squared. Then the visualization part. And this is the part that I was talking about before, about the prediction of airplanes. It might happen that actually what you're trying to predict it has different ways to show the data. Maybe sensor data, you want to analyze it like this, like for example, the real values on the top and the predicted values are on the bottom. Or it might happen that actually you want to understand the phases on the airplane. One thing I didn't explain about the airplane use case is that we were analyzing hydraulic pressure of the pumps. And there was a problem because actually an airplane is like stuck in the ground, then it's trying to take off, then it's like flying, and then it's going to descend, and then it's landing again, and then it's on the ground again. And in those different phases, the pressure pumps actually goes really high or really low, depending on the case. And you want to understand like the difference, the slight difference for each phase. So one thing that actually we did was try to divide all the, let's say, the pressure itself divided by the type of phase that you are, because it makes sense that in the phase that you are taking off, the pressure is really high. But if you have really high pressure when you are actually flying, when it's supposed to be like really normal, then you might have a problem, and that's why you want to see it in a different graph. So it really depends on the problem that you want to attack, and how do you want to visualize the different, let's say, outliers. In this case, it could be an outlier, it could be that the pressure actually goes really high. I think, yeah, this is really it. So I'm gonna handle it. Yeah.
So hi everyone. In this part, I will present a real-world example by taking an example from a company you know, I guess, which is Bosch. They are quite known because they have often a cutting-edge technology for their process, etc. And so I will use this example to show you an example of predictive maintenance with the different steps of analysis of the data, of modeling, and on how to evaluate the model. So the data come from vibrations that come from mailing machines. So there are 3 machines, each one with 14 processes, and for each process we have their vibration data, and there are 2 files, one with the good vibrations and the other one with the anomalous vibrations. So then we have some details about the sampling rate, which is 2 kHz, and one particularity is that it's 3D data. So we have the information for the 3 axes, and also it's discrete data. It's not continuous in time. it's basically the data between February and August 2019, then between February and August 2020, and then between February and August 2021. So it's something to take into account when you have discrete data, is that the process or the mean of measurement can change in time. So yes, vibration data can be different. For example, if you made a change in the processes between 2019 and 2020, the vibration will be different. And so the models, etc., might be different. So to do the exploratory data analysis, then we have a problem, a business problem, like Andre said, is that we want to prevent fabrication problems because mailing machines are responsible to produce PCs due to a machine default. Because if the vibration of the machine are wrong, the PC's dimensions, for example, will be wrong. And even more so, the vibrations may also further damage the machine, and so it will reach its end of life sooner. And so we join also what Andre said, it's less costly and less time consuming to do predictive maintenance than reactive maintenance when the machine doesn't work anymore, or when you have a lot of bad pieces because you can't sell them to clients at some point. So the particularity of these data sets is that since it's vibration, we can have two point of views, either in the time domain where you have the chronological values of the machines, but also the frequency domain, because vibration are frequencies, and so you can study them. And so it's interesting, it's explore data analysis to separate both and to maybe apply different treatments of the data in the two different cases. To have data visualization for the time domain and for the frequency domain, for example. Another particularity is that it's a large data set because each machine has 14 processes, like I said, but also in total we have several millions of data because it's different process, it's different machine, etc. So it's really a lot. So often it's good to have a lot of data, even always it's good to have a lot of data. But in this case, and it's quite common in classification problems, we have a labels disbalance because there are a lot of good data than bad data. And so I will explain it later, but it's hard to evaluate the model performance with some metrics. Because it causes problem to determine what are the bad patterns compared to the good one. And also we have a choice to make, and I will explain it later also when I will talk about the choice of models, because we could do visualization about the machine for each machine. We can distinguish the machine 1 with the machine 2 with the machine 3, etc. We can also see by process or by channel, because we could have different values, interesting values for each axis. Or we can also transform them into 2D, but it's according to the treatment you want to do. Maybe in some points it will add a feature to have 2D information, but in other situation it could not be interesting. So it depends on the context. So basically to do a workflow about the predictive modeling. So first we do approximately what Andre said. We do the data cleaning and the extraction of data, etc. Then we have the model training part in itself. So in the beginning, you start with default parameters that are the common ones for each models. Then you try to improve the performance of the model iteratively. Let's say it at the end, but I can say it. No, basically it's a loop where you do you set parameters, you evaluate the model, and you try to minimize the loss. Basically, it's the gap between the real data and the predicted data, to optimize the cost, which is the sum of the loss. And then you try to improve step by step the different parameters of the model. So each time you come back and you improve the loop. Okay, so in our case with the Bosch data, we have a classification problem because basically we have vibration data as inputs, and we want to try to know if it's a good vibration or a bad vibration. So in our case, since the labels are disbalanced, as you can see, we have hundreds of millions of samples for the OK, but only 5 million for the non-OK. So it's an imbalanced binary classification. And so we have several ways to prepare the datasets. So basically, we start from an original set, and when we don't have a lot of data, we basically cut it into the training set and the test set for the model. So it will use a train model to test it against the test data to evaluate the performance. But in our case, we have a lot of data, so we can have three splits. So the training set and the validation set that are used during the training to fine-tune and evaluate the model. And at the end, we have the test set that is used to evaluate the final model to see if it generalizes correctly or if it's only good during the training. So since we have a large data set and the labels are imbalanced, we can choose to select a subset of samples if we have memory, for example, or time or size limitations. We also can put weights in models. We can put, say, the bad values, since there are less, are more important. Or we can also do up and down sampling to augment the frequency values, to artificially augment the presence of bad values. And also in the end, for the model, for the training, we have also different choices. Like I said, for the visualization, we can train one model on the machine and test it with the others. We could train a model on each machine and at the end aggregate the results to know for each machine which vibration are good or bad. Or we can also use all the machines as input for the model to train the model. So again, it depends on the context. Sometimes the machines are really different and you can't aggregate the result. Sometimes some machines have specific features that you can use to distinguish between them for a model. It always depends on the context.
Oh, sorry.
So then to choose a model, I present three quickly, because in the end it's mostly to show the advantages and downsides of some models. So I will start by the simplest one, which is a decision tree, where basically you start from a node, which is a feature, the edge, for example, and then you have you have different possibilities to go to the next node. So for edge, if it's inferior to 18, you have 08, etc. And at the end, you do at the lowest level of the nodes, you do your decision. So this kind of model is very good when you want to have transparent and explainable decisions, because well, you just have the tree, so you can say, okay, I arrived at this choice because I did this. So you have a set of explanations. But the problem is that it's rather simple. So when there are complex, non-linear, or things like this, relationships between the variables, it can be hard to just have an explainable tree. So in this case, you have several choices. You have regression models like linear, polynomial, etc. And in this case, it's XGBoost regression. We should. Yeah, it's fine. Yeah, right. So yeah, the decision tree is a tree on the right, and the XGBoost in top left. So XGBoost also work with trees, but it's invisible trees, where basically you start from a basic model where you will just use a mean to do predictions, for example. Then you will evaluate the loss, and according to the result, it will improve the model, the trees itself, to improve the predictions. And then at the bottom left, you have the artificial neural network, which is basically a superposition of layers that you use to extract the important features of the data and to make a prediction for them, from them. So yeah, to summarize a little, yeah, won't enter into the detail, but an important thing is the performance. When you use a decision tree, since it's simple to start trees for a computer, you can just use your CPU. But mostly for AI models, it's often interesting to run it on the GPUs, because often the CPUs are like have like 8 cores, but a GPU have a lot of little cores that works in parallel. So it's really useful to accelerate the prediction, the training of models, because it's really specialized to run several operations at the same time and in a parallel. And then to come back to the metrics that Andres presented, but I didn't put the formula because you can find them easily online, but the most important thing is to understand what they say from the models. So the precision, for example, that show how many predicted true positives are really true positives. The recall, does the model captures well all positive cases? So in our case, does it classify well the good vibrations? And then we have the F1 score that basically is balance, precision, and recall. And there is also accuracy, which is a proportion. Yeah, I will answer at the end. So for the accuracy, yeah, it's basically to evaluate the proportion of correctly classified labels. And it's not a good metric in our case, and in general for when we have unbalanced labels, because the model can just learn to just predict the majority class, and it will have a good accuracy. For example, we have a lot of good vibrations, so the model can say good, 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 good each time we give a vibration as inputs.
Yeah.
And it will output good, and it will have a good accuracy because it's a majority class. So, and we don't want that. Yep. So to conclude on the use case, yeah, you need each time to think about how you will evaluate your model, about the metrics you will use, about what you want to say from the results. But what you need to keep in mind is that the performance are mainly given by the quality of data you give as inputs, because if there are missing values or big outliers that are anomalies in the data, the model that will learn about them, and you will see the impact on your predictions, so they will be less good. So the quality of the data is the first thing to improve. The size often is more useful to have more data than always, but then you have memory or size limitations for the training. So each time it's a balance. About the diversity of the data, if you have a lot of features, like for airplanes, you have a lot of sensors, etc. You need to select or study during the data analysis what features are the most important, etc. And then comes the improvement of the chosen model, or you can even try different models and see which one works the best. You have the decision tree. I won't come back in detail about that. But what is important to understand also is the trade-off, because everything again is a balance between the bias and the variance. And so basically the picture here, you, according to the context and according to what you want in the end, you want to, at the same time, have a model that works well on the training data. So be close to the real value, like here, with low bias and low variance. So here it's a perfect situation. But also you want to have a model that is that you can generalize to use it with data that are not in the training data sets, to be as close as possible still to the real values. And yeah, so at the end, the goal is to have an optimal value where you don't overfit, so which means have a model that works only on the training data, but is really bad for another data set of the same data. But not to be underfit, so it's a model that predict pretty much randomly if it's unfit. But it might be good to generalize it. Yeah, and then in the performance, the GPU, when you have a lot of, when you use no network or more memory consuming, in the sense memory, computer memory, it's better to use a GPU, way better even, to use a GPU. And yeah, for data pipelining and model performance monitoring, you have tools that you can use when you deploy your things, like MLflow and kubeflows, which is into Kubernetes, where you can monitor really your AI pipeline and see the influence of training, etc. And of course, you have a lot of different neural networks. I just presented it in general. But some are best for images, some are best for time series, some are best according to the parameters you give to them. If you have a lot of knowledge about your data and you do a big data analysis, you can really fine-tune the parameters and have a good performances. So it really depends on the context, and you have a lot of choice, but each time it's a balance. And yeah, so I'm done.
Okay.
And let's Andres speak again.
Yeah. So some challenges and best practices. First of all, to answer the question of Alejandro. So one of the tools that he was mentioning here, for example, is the tools that we are using. You can see the cursor, but I'm pointing to MFlow and Qflow. But there are more tools. Like for example, this is not just for the predictive part, but also for the data part. I'm going to explain now also. So some challenges and best practices. Technical challenges. Usually the really complex part, and this I agree with a lot of people doing data science. They tell me that actually managing the data is 80% of the problem. Usually, it's like how the data is ingested, how actually we put it in a database, how we analyze it, how we do the data cleaning or the feature engineering, and then the modeling part is also important. It's a lot more important, but combining the data, understanding if actually is that related to what is needed is really complex, and in some cases it takes longer. Do you use some level data? Okay, they're asking something more. So technical challenges, data ingestion usually is because actually they don't come with the same formats. Every API actually decides how they're going to share the data, how. That is changing a little bit by using the data catalogs. In some cases, that actually it tells you some metadata on how the data will be structured, which is really good, but it's not in all the cases. Multi-format data. In some cases, we have structured data in databases, or unstructured data like text files or annotations, and semi-structured data like JSON files or XML, which they might cause a problem if they have a lot of unused data. And then also you have streaming data, which actually are pipelines that are streaming information all the time. And then probably if you cannot handle all the data, you need to select exactly what to use, and what you cannot really process, you need to discard it. Then after the data ingestion, the problems are the data storage. Like, where should I save the data, or how? You have the traditional databases that there are relational databases usually. Data lakehouse, that actually they are like data stores for different type of data, and the problem is that when nobody maintains that is really hard to understand where the data is or how the data is structured. And then specialized databases like time series databases or graph databases, it really helps to analyze the data or to try to understand the data at some point. Then is the data quality. Like, for example, if the data is incomplete or noisy, it happens all the time. The governance also, like the data privacy issues that you might have, it happens a lot of time when you're working with a partner that they don't want to share the data because they might have problems with GDPR. GDPR started as a law in 2018, if I don't recall wrong. That is the issue of sharing personal information or ways to locate people through the data. Lack of contextualization, like sensor data alone is not enough if you don't have metadata, for example. And then also the data processing part is like feature engineering process. They need to happen somewhere. ELT, ETL processes also, they need to happen somewhere. And that means that actually you need to have computer power and also like a way to store the data before to actually have these processes. These are some of the data challenges or technical challenges that we have with data, but also we have human challenges like resistance to change or continuous formation. It happens all the time. Okay, what tools should I use? Should I use this tool? Is my team actually good enough to understand that they can switch to another language, another programming language? Will anybody understand how to maintain something that I do? Not just because I do nice comments, but also like they know how let's say the programming language that we're trying to use. So, for example, we have this challenge in our team, and at some point we decided that we should go for tools besides the tools that maybe are common or like really how do you say, like non-proprietary decisions. Non-proprietary tools, which are the ones that are here, for example, are non-proprietary. It's good because in some cases you are not depending on only one vendor, but it also happens that actually if you have your solution that it works in one vendor, maybe in another one, or if that vendor actually doesn't give you support at some point, you are stuck with your solution and you cannot improve it. So there are different kind of solutions that can help. I don't know if that answers the question of the tools to use or that we recommend, but it really depends on the cases. For example, here is the stack that we are trying to implement to process the data, because we have like different sources of data and we wanted to add them into a storage that actually makes sense. And from there, we use another storage, which is an open table format, which is Iceberg, for example. So we can actually have not only the data itself, but the structure of the data. So let's say from scrap data, we went to not directed to relational databases, but the way to have the relational databases and then to have aggregated data on that. That allows us to help other teams to actually share the data with other teams in one part, and that actually means that actually all the teams are not working with the data as they want in their own domain, meaning that actually we are trying to have pipelines that actually make sense to everyone, not only for us. Yeah, that's pretty much it. And then the last one. One thing that I want to comment was that actually one of the strategies that we have also is that having pilot projects. Pilot projects, they can actually act as control experiments before full-scale deployments. It's really, really important to have this, because actually it's a one first step to really have an idea if I validate the feasibility of the project, if the machine learning, the model that I'm trying to use is good enough for the project I want to solve. If I can optimize the implementation at some point. Laurence, I don't know if you want to add something here.
Can you hear me? Yeah. Well,
yes.
I just wanted to thank you and to tell our participants that, as they can see, there are many challenges to doing this predictive maintenance and implementing the right tool for your right organizational context and maturity, and that we at DIH, we are here to help you within the project. So please call on us. We'll be glad to support you. So feel free for the next step to attend the hands-on workshop that will take place on June the 19th, if I'm right. And contact us. I think the contact details are in the next page. And we will send you the slides anyway. But feel free to call for us, and we will be more than glad to support you in determining the right approach and technical solution and implementation for your company. Thank you.
Thank you very much, Andres and Arthur, and also Laurence, for this insightful presentation and the test before invest services. Please keep an eye also on our event page, as there you have the opportunity to follow up with our webinars, but also with our workshops.
Okay.
Next DIH talk will take place on the 25th of April, and it will be about visual inspection, also presented by the Luxembourg Institute of Science and Technology. So, as Laurent said, at our event page, there will be also the possibility to register for the hands-on workshop on predictive maintenance. So thank you very, very much for joining, and I hope you have a great day. Thank you.